This is page 340. And this page doesn't have a lot of things for a student to complete, but there's a lot of reading to do. So I suggest you watch this video closely, read along with me, I'll read it to you, read along with me, practice your reading skills, and then trying to understand what we're talking about here. Describing relationships between independent and dependent variables. Thinking about how one quantity depends on another helps you identify which quantity is the independent variable and which quantity is the dependent variable. In a graph, the independent variable is usually shown on the horizontal axis and the dependent variable on the vertical axis. We kind of alluded to that on a previous page. So the independent would be the x-axis, and the dependent would be the y-axis. That's what this is saying. So the independent is usually the x, and the dependent is usually the y. Okay. Example 1. The table shows a relationship between two variables, x and y. Describe a possible situation the table could represent. Describe the independent and dependent variables in the situation. So what we want you to notice is that the independent variable x goes from 0, 1, 2, 3, and the dependent variable y starts at 10, but it also goes up by 1, so it goes 10, 11, 12, 13. So here's the conclusion that this is the kind of thing that you should be able to notice. As the x increases by 1, y increases by 1. The relationship is additive. The value of y is always 10 units greater than the value of x. It's additive because whatever I give you here, let's say I skipped, instead of putting instead of going in order and putting a 4, let's say I just put a 7. Well, we know that this one would be 17 because every single time the y is 10 more than the x. So it's called additive because whatever I put here, I would just add 10 to get here. Okay. All right. So what could that represent? The table could represent Gina's savings if she starts with $10 and adds $1 to her savings every day. The independent variable x is the number of days she has been adding money to her savings. The dependent variable y is her saving after x days. So what we're saying here is what this could be is that the independent variable x is the days, and this is the savings. And so after 0 days, she had $10. After 1 day, she has 11. And why is that? Because she always adds $1 to her savings every day. After 2 days, she has 12. After 3 days, she has 13. All right, let's move on. B. The graph shows a relationship between two variables. Describe a possible situation that the graph could represent. Describe the independent and dependent variables. Once again, this is what we should be thinking in blue. As x increases by 1, y increases by 12. Let's see if that's true. 1 has a value of 12, 2 has a value of 24, 3 has a value of 36. So every time we go up by 1 on the x-axis, we go up 12 on the y-axis. The relationship is multiplicative. The value of y is always 12 times the value of x. So what we're saying, how this one's different than the last one, is that as we increase the values of x by 1, we increase the values of y by 12. We're multiplying by 12. We're not adding in this case. So what could this represent? The graph could represent the number of eggs in cartons that each hold 12 eggs. So this would be the cartons, and this would be the eggs. And that should make sense because if you have 1 carton, that would be 12 eggs. If you had 2 cartons, that would be 24 eggs. If you had 3 cartons, that would be 36 eggs. If you had 4 cartons, it would be up here, it would be 48 eggs. All right. Reflect number 7 says, what are other possible situations that the table and the graph in the examples could represent? Now there is I know there's a million possibilities here. So we're going to start by saying that the answers vary on this. I'm more than happy to share my answers with you, but I want you to be clear that the answers vary. There's not a right answer because it says, look at what it says. What are other possible situations that the table and the graph could represent? All right, so let's come up with a couple of examples. So to have a good conversation about this, we need to go back and look at the table and the graph. So let's go back to the table. And earlier we talked about how this could be days and savings. But it could also be something else. It could be like a DVD collection or something like that. So this could be a total number of DVDs. And let's say that somebody has a collection of DVDs and they start at 10 right here. And then let's say they decide they want to add to their collection. So every day they add a DVD. So after 0 days, Paul has 10 DVDs. And then for every 1 day, you add a DVD. So after 1 day, he would have 11. And after 2 days, he would have 12. And after 3 days, he would have 13. So I'm going to go ahead and put that into words. And we'll do the graph example in just a minute. So remember we said the answers vary here. But you could say something like this. I just made up a name. Paul collects DVDs and has 10, but decides to increase his collection by buying 1 per day. That's good enough for that. We described it good enough. Now we're going to add to this answer because we have to also come up with an example for this x-axis, or for this one right here, for the graph. All right, so if we have 1 would be 12, 2 would be 24. This could be like money. So how do you make money? Usually you make money per hour. So let's say you have hours here. And so this right here this number right here would be 1 hour, and this number would be 2 hours, 3 hours, 4 hours. And what happens usually is you make money per hour. So this could be $12 for 1 hour, $24 for 2 hours, $36 for 3 hours, and then the next one would be up here. It'd be $48 for 4 hours. So how can we describe that? Well, it's real simple. We can describe that simply by saying you earn $12 per hour. And I'm going to describe that the x-axis is hours and the y-axis is money earned. All right, good enough. We are done with page 340.